Hello and welcome. In the earlier lessons, we have learned about the data types and qualifiers used in the C language. Data types tell the compiler how to interpret the data stored in a variable, and the qualifiers are used to define the range of a variable. In this lesson, we shall learn about the storage class. It is a characteristic that defines the scope and permanence of a variable. The scope defines the portion of a program in which a variable is accessible. C defines four different storage classes. These are automatic, external, static, and register. And these are identified by the keywords auto, extern, static, and register respectively. Storage class of a variable sometimes is established by the location of its declaration statement. In other cases, the storage class keyword must be explicitly specified. As shown in the examples, the storage class keyword must be specified at the beginning of the declaration statement. Let's understand the storage class in detail with examples. The variables defined inside a function are automatic by default. It is not mandatory to mention the keyword auto with the variable declaration. These are also called local variables as their scope is confined to the function these are defined in. Hence, an automatic variable is recognized when program execution enters the function defining the variable, and the variable goes out of scope when the program execution exits the function. The formal arguments defined for a function also falls in the category of automatic variables. Functions may define automatic variable with the same name and these do not interfere with each other. A function may define an automatic variable with the same name as a global variable too. In such case, the local variable takes precedence over the global variable. An automatic variable should be initialized before its usage, else the value will be unpredictable. In the example shown, the variables achar and index of types character and integer defined in the function main are automatic variables. Note the keyword auto is omitted. The variable defined outside a function, usually at the beginning of a source file, are external variables. The keyword extern is not mandatory in the variable definition since the location of the definition identifies its storage class. These variables are accessible across the functions from the point of their definition. Due to this, external variables can be used to pass information between the functions. However, due care must be taken as the change in the value may be unexpected in a function, resulting in subtle programming error. When an external variable is used before its definition or in different source file, it must be declared. The declaration of such variable must contain the extern keyword and the identifier and the data type must agree with the corresponding definition. Usually, external variables are initialized with a constant value. If uninitialized, these variables are initialized with 0 by the compiler. However, it is a good practice to initialize the variable. In the example shown, the variables fun underscore level, sp underscore level, stack underscore level, sp underscore ASCII, and data underscore ASCII are external variables. Note some of the variables are initialized and others are not, and the keyword extern is omitted. Static variables defined within a function have the same scope as that of automatic variables. However, the static variables retain their values throughout the program execution. Thus, if program execution has exited a function and re-entered later, the former value of the static variable defined in the function is retained. The definition of the static variable must start with the storage class specifier static. Similar to the automatic variable, static variable may share the same name with the external variable. In such situation, the local variable takes precedence over the external variable. Though the value of the external variable is unaffected by any manipulation of the local variable. Static variable can be initialized with a constant. The value will be assigned to the variable at the beginning of the program execution and can be changed during the program execution. An uninitialized static variable is assigned the value 0 at the beginning of the program. The global variable may also be defined with static keyword. In such case, the variable is accessible only inside the source file defining it. The example shown prints the first 20 number in Fibonacci series. The function defines the static variable f1 and f2, which are initialized with the values 1 and 2 respectively. The value of static variables are modified in each call to the Fibonacci function, and the static variables f1 and f2 retains the value in each function call. Some programs are time critical and it is desirable to reduce the execution time. For such programs, the variables used in function can be placed in the registers provided by the microcontroller. It reduces the time to move the data between memory and the register. The keyword register is specified at the beginning of the variable definition. The compiler tries to allocate microcontroller's register for such variable if register is available. However, this is not guaranteed and there is no mechanism to know if the variable is allocated a register. If register is not allocated to the variable, it is treated as an automatic variable. The storage class register has the same characteristics as that of automatic variable. The scope and rules governing the storage class are the same as that of automatic variable. The only exception is the address operator can't be used with a register variable. Usually, the storage class register is associated with integer type variable and pointer. We shall learn about the address operator and pointer in later lesson. The formal argument of function can be defined to be a register variable. The example shown is the variation of the program to print the first 20 number in Fibonacci series. The static variables f1 and f2 defined earlier are defined as register variables and initialized with values 1 and 2 respectively. The storage class specifier extern and static are also used to define the scope of functions and global variables. The scope of a function defined in a source file can be limited to the file if it is defined with static keyword. Such functions can't be called from the other source file. A function by default is defined as external, but to call the function from a source file, the storage class specifiers extern and static are also used to define the scope of functions and global variables. The scope of a function defined in a source file can be limited to the file if it is defined with static keyword. Such functions can't be called from the other source files. The function by default is defined as external, but to call the function from the other source files, the function declaration must be placed in those files. It is a good practice to specify the extern keyword in the function declaration. Similarly, a global variable defined with the static keyword has a scope in the source file where it is defined. The global variable defined as static can't be used in other source files. However, To make a variable accessible in other source file, the variable declaration must be placed in those files. The variable declaration should mention the extern keyword and the definition should not contain the static keyword. The function and global variable declaration must agree with its definition. With this, I conclude this lesson. I hope it was interesting. Thank you.